Hey guys, so today we're going to be doing the second video of the circuit analysis series. And just like in the last video, if you haven't seen it already, I advise checking it out. But just like in the last video, I'm going to be solving a practice problem, and I'll explain the concepts while I'm solving it. So as you can see, for this problem here, there's multiple power sources, unlike in the last video. And it's still a DC circuit, but there's multiple power sources, which will make it a bit different to solve, though I argue it's actually a bit easier to solve than the previous problem. And so our task is to find the current in each of these three resistors, and these are the power cells with the EMFs. And so before I start, I'm going to say which rules we're going to be using for this problem. So just like in the last video, we're still going to be using Ohm's rule, which is just that the voltage, the current, times the resistance. However, since there are multiple power sources, we can no longer add resistors in series and parallel. But there's two new laws that we can use, and they're known as Kirchhoff's, I hope I spelled that right, circuit laws. And there's two of them. And so the first one is known as Kirchhoff's junction rule. And before I say what it is, first let me just establish what a junction is. So if you've ever driven a car, you would know that a junction is sort of when the road forks off. So the car has to sort of choose between going here or here. And in circuits, it's pretty much the same principle. So it's basically where the circuit branches off. So like for instance, this would be a junction and this would be a junction because the current has the circuit branches off at these points. So now that we know what a junction is, the junction rule basically states that the current that is going into a junction or entering a junction is equal to the current that's exiting a junction. And this can also be written as the sum of the currents at a junction is zero. I prefer the first one though, because I don't like to think of currents as negative. And then the second rule is Kirchhoff's loop rule, and it basically states that the sum of the voltages around the closed loop is zero. And like I said, this is only for a closed loop. And the closed loop is, well, it's pretty self-explanatory. This is one closed loop, and this is another closed loop. And in the problem, I'll actually be dividing in half. So yeah, these are the three formulas: Ohm's law and Kirchhoff's circuit laws. And the problem is asking us to find the current in each resistor. And first, let's look at this junction here. So first we're going to say there's one current going through this loop here, loop 1, and I'll call this loop 2. The right loop is loop 2, and there's another current going here, and I'll just call this one I1, and I'll call this one I2. And yeah, I know that there's two power sources here, but because this one has a greater EMF, I'm going to just say there's one net current, which is going this way, and I'm going to call that I1. And here there's only one power source, so it's pretty easy to figure out. So this current will just be I2. So then using Kirchhoff's junction rule, we know that the current I1 has to be leaving this junction because it's going counterclockwise, my bad. And current 2 is also going counterclockwise, but since it goes in this loop, it'll be entering the junction. And this will be current 2. So then using Kirchhoff's junction rule, so I said that it was that the sum of the currents at a junction is 0. And then I also said that so I2 is entering and I1 is leaving. So then we have I2 minus I1 plus, and I'll just say question mark, equals 0. And the reason why this question mark is because I don't know what the current here is, at least not yet. So then we said, so I'll just rewrite that. I2 minus I1 plus question mark is 0. So then we can just say that question mark is just equal to I1 minus I2, because then that would fulfill this equation. So the current entering this junction here is I1 minus I2. Or we could also just say that the current leaving that junction is I2 minus I1. It really doesn't matter. It means the same thing, but because they're both going the opposite directions and they're both opposite currents, so it sort of cancels out. So these basically mean the same thing. I'm just going to say that the current leaving this junction is I2 minus I1, just because. But it really doesn't matter. So in that case, question mark is equal to I1 minus I2. But since it's going downwards, we're going to say that the current going through this resistor is I2 minus I1. And then we know just from looking at the other resistors that this is just I1 and the current here is just I2. So we can say that current going through the 2 ohm resistor is I1 and the current going through the 5 ohm resistor is I2. And now we can begin to use the loop rules for each of the 2 loops. So first let's look at this loop here. So let's just draw a line here so we can just split it up. So we're going to say loop 1 is the one here on the left that's has current going here. Loop 2 is the one here on the right which has a current going kind of like this. So first let's look at loop 1. So then we said that the loop rule was that the sum of voltages around the loop is equal to 0. And for loop 1, we start with an EMF of 20 volts. So if I go back up, yeah, here. So the positive end of this power cell is the same direction that the current is traveling in. So I'd say that that's positive. And here the current reaches its first resistor, which has a resistance of 2 ohms. And since it's a resistor, it goes against the current. So we would say minus 2 ohms times the current, which we said was I1. And going back up here, it goes through this power cell, and notice that the plus sign is this time like facing the opposite direction that the current is going in. So this would be minus 14 volts, and we're almost done. So now it goes through this area here. But I said that the current going through here was I2 minus I1, so we're going to use that instead of the current I1. And I2 minus I1, I said went down here, and actually it's better that I pretend the current's going up, so then the current going up would be I1 minus I2. And then this would be resisting that, so yeah, because I want it to go in the same direction as I1, so I'll say that the current going up here is I1 minus I2, and it's resisting it, so I have to subtract. So then I get minus 4 ohms I1 minus I2. And if we clean that up, we get 6 volts minus, actually I'll just get rid of the ohms, so 2I1 minus 4I1 plus 4I2. And I'll actually get rid of all the units for now. So it's just going to be 6 minus 6 I1 plus 4 I2. And this is equal to 0, according to Kirchhoff's loop rule. And now let's look at loop 2, or the loop on the right side. So in loop 2 is, actually I think it'll just be a lot easier if I draw it here. So we have the power cell, and we have the resistor here, and we have another resistor here, and we said that the current, and this current 2 goes here, and then we said at the junction that the current going up was I1 minus I2. But since we sort of want to make this easier on ourselves and the current's going like this, we'll just say that the current going down is I2 minus I1, and then the resistance here is 4 ohms, and then the EMF here is 36 volts. So then if we do the loop rule, sum of the voltages, so we start off here, it's 36 volts, and we said the resistance of this resistor is 5 ohms. So minus 5 ohms times current 2. Then we have current I2 minus I1 going here. And then the resistor's resistance is 4 ohms, so minus 4 ohms times I2 minus I1. And this is equal to 0. And to make this easier to solve, or easier to look at, I'm going to get rid of the units. So I'm going to have 36 minus 5 I2 minus 4 I2 plus 4 I1 is equal to 0. Then 36 minus 9 I2 plus 4 I1 is equal to 0. And now we can actually just make a system of equations. So I said 36 minus 9 I2 plus 4 I1 is 0 just now. So I'll just say that's the first equation. And here I said 6 minus 6 I1 plus 4 I2 is 0. So 6 minus 6 I1 plus 4 I2 is 0. And so I wanted to get rid of one of the variables, so I can solve for the other one and then solve for the original one. So what I'll do is I'll multiply this one by 3. So now we have 108 minus 27 I2 plus 12 I1 is 0. And you'll see why I did that. So this is, I multiplied by 3. This one I multiplied by 2. So I have 12 minus 12 I1. And now you see why I did that. Because the I1s cancel out. And plus 8 I2 here is 0. So all I have to do is add them up. And I get 120. So the I2s don't cancel out. Minus 19 I2 is 0. And the I1s just cancel out since they have the same coefficients but opposite signs. So we get that I2 is equal to 120 over 19. And when I plug that into my calculator, so it's 120 divided by 19. And we get that it's about 6.32 amps. and then I1. So all we have to do is plug it in. So for I2 now we have 36 minus 9, 6.32 plus 4, I1 is equal to 0. So then we get I2 is 9 times 6.32 minus 36 over 4. And please excuse those noises. Out of my control, unfortunately. But I'm making a YouTube video here. Sorry. Okay, so 9 times 6.32 minus 36 over 4. So that is just 9 times 6.32 over 4 minus 9. Actually, it would have been easier to plug in the first one. So 9 times 6.32 divided by 4 minus 9 is about 5.22 amps. And this is current 1. And finally, so I go back up to the circuit. Okay, current 1, current 2. So current 1 is going through the 2 ohm resistor, current 2 is going through the 5 ohm resistor. And current, let's say I2 minus I1. Actually, no, I have to find which one's greater. So current 2, we said, was about 6.32 amps, and current 1 was about 5.22 amps. So if we want a positive current, we'd have to use current 2 minus current 1. So then the current going through the 4 ohm resistor is just current 2 minus current 1. So this is about 1.1 amps. And then this is the current going through the 4 ohm resistor. This is the current going through the 2 ohm resistor. And this is the current going through the 5 ohm resistor. And yeah, so that is how you find the currents going through a DC circuit with multiple power sources. And it looks like a lot, but it's not. So basically, a brief recap is that there's 3 rules we use. We use Ohm's law and Kirchhoff's circuit laws. The first Kirchhoff circuit law is the junction rule, which states that the sum of the currents at a junction is 0. The second one is known as Kirchhoff's loop rule, and it basically states that the sum of the voltages or potential differences around a closed loop is 0. And using these two loops, not loops, sorry, these two laws, I eventually found all 3 of the currents going through each of the resistors. And that is all for today. I hope this video helped, and thank you for watching.